name is Mark Fudge, and I'm the innovation responsible inside AST Modular. And today my goal would be to present one of our modular narrow-free cooling solutions that is embedded inside our data center cooling family. The main features of this product is energy efficiency. We are capable to provide extremely energy efficient PUEs in today's data center as low as 1.1 upon worldwide location, obviously. And this is due because how the system operates is that is based in air-to-air exchanger, and therefore the main source of cooling is through air. Second feature of this product is security. Security-wise, there is no cross-contamination of air. In other words, the external air that we use towards the internal air that is captured from the data center is never crossed, and therefore there is no external crossing of that air, as well as no humidity interference from the outside air. And the third feature that I would like to point out is scalability. Scalability, these units comes in 50 kilowatt power per block or per unit, and this can be integrated either in data center type of deployment or traditional data center, as well as containerized data center. The only thing that we have to provide in order to scale as the customer needs is to provide different number of modules, 50 kilowatts each, and therefore upgrade the power of the customer to whichever the level is. In other words, if the customer needs 200 kilowatts day one, they will install 4 units, and then in the future they can grow, they can upgrade, they can install these units plug and play to provide more power. How the unit works is basically captures the air from the hot corridor or from the plenum of the data center towards the air-to-air exchanger or the air-to-air economizer, which is crossing external air towards the top side and lowers the temperature again on the cold corridor side of the unit. There are 3 basic stages of operation on this unit. Stage 1, it's when the air-to-air exchanger is providing full load. This means that in order to provide 24 degrees on the cold corridor, the external air as an average has to be 20 degrees Celsius or lower. If that is not possible during certain amount of time a year, then we have adiabatic cooling, which is placed on that window over there, which will be providing the additional cooling power that is needed to provide that 50 kilowatts of power per module. And then if there is not a sufficient external temperature and relative humidity might be too high to use adiabatic, then we have an additional coil here, which can be a chill water coil or direct expansion evaporator in order to provide the additional power that the unit is needing. All these units are totally independent one to the other one, so redundancy is embedded in the modules, and therefore we are providing an independent CPU on the unit, as well as a totally independent electrical switchboard in order to provide the redundancy per module and not as a whole system. If we are deploying, for example, a containerized solution, we can integrate up to 400 kilowatts in a 40-foot container, so that gives us a really nice densities for this type of deployment as well.